Okay, today we're going to work on 7.2, multiplying mixed numbers. So our objective today is to be able to solve real-world problems using multiplication of fractions, including mixed numbers. So for our mental math here to get started, we're going to determine whether the number sentences are true or false. So let's look at each one here. I have 1/2 multiplied by 3 is greater than 3. Think about whether that's true or false. Remember, anytime you multiply an integer or a number by a number less than 1 or a fraction less than 1, it's going to be less than your original factor. So let's see. If I think about this, 3 times 1/2 should be less than 3. But let's just test that out and see. So I multiply. And when I convert it to a mixed number, I get 1/2. So 1/2 times 3 is greater than 3 is false. Try the next one there, 5/6 and 3/5. Is it going to be less than 5/6? So when I look, my original factor is 5/6. My quotient there, or sorry, the product they're showing is 5/6. But when I multiply these two together, I'm multiplying by a fraction less than 1, so it would be less than my original factor, so that is true. Look at the next one here. They're saying 2/2 is what I'm comparing. My original factor is 2/2, but I'm multiplying it by 3/3, which is equal to 1/2. We know any number multiplied by 1, or any factor multiplied by 1 is simply itself, so that is a true statement. They are equal. Our next round here. Go and pause the video, take a minute and look at those, and decide if they're true or false. Okay, hopefully you've had a minute to study those. Let's go ahead and look at these together. Again, I see I'm comparing it to 3/4. 3/4 is my original factor, but I'm multiplying by 5/6, which is less than 1. So 5/6 multiplied by 3/4 is true. It'd be less than 3/4. The next one here, I'm comparing 7/3 with this factor. 5/5 is equal to 1/2. So I know 7/3 times 1 would be 7/3. That is not greater than, it's equal, so that would be false. 6 1/4 times 7/9 is less than 6 1/4. Okay. When I look at that, I can see that that is a true or false statement. Let's see. Our original fraction there, mixed number, is 6 1/4, and then we see 6 1/4. I know that this factor of 7/9 is less than 1, so any fraction 6 1/4 multiplied by a fraction less than 1 would be less than 6 1/4. So that is true. And then one more round here. Let's take a moment, see if you can figure these two out. Hopefully you had a chance to look and think about those. I see here I have 8/8, which is equal to 1, multiplied by 12/12. And I know that factor is equal to 1, so it's essentially saying 1 times 1, and it would be equal to 1. So that is a true statement. So look at this one. I got the factor 3/16, I'm comparing to 3/16. I know that 9/7 says more than 1, so it would be greater. So that would be a true statement. Now we're going to watch a little video here about improper fractions and mixed numbers.
We speak students!
Improper fractions and mixed numbers, a la schmo. Numbers come in all shapes and sizes. Some are big and some are little. Some are whole, and others are a bit fractured. As far as fractions go, it's a mixed bag. Some fractions are proper, some are improper. And then there are those that are just a little mixed up. Who am I? Proper fractions have a numerator that's smaller than the denominator, which means they're always less than 1. Proper fractions also donate to charities and volunteer in soup kitchens. They know they're not greater than anyone else around them. Improper fractions, on the other hand, are a little full of themselves. They've got big heads, well, big numerators anyway. In improper fractions, the numerator is bigger than the denominator, which means they're greater than 1.
Odd 1.
Since fractions aren't supposed to be greater than 1, we call these guys improper. They're a bit on the rude side.
Well, I never.
But if they get on our nerves, we can change them into mixed numbers. Mixed numbers are combinations of whole numbers and fractions. so they may be a bit confused at times. Maybe they're going through an identity crisis or something. We don't really know.
Am I a whole number or am I a fraction?
We can change improper fractions into mixed numbers by dividing the numerator by the denominator. That's what fractions are, right? Division. We'll end up with a number and a remainder. The number is the whole number in front, and the remainder goes in the numerator of the fraction that follows it. If we're sick of being mixed up by mixed numbers, we can change them back into improper fractions too. Since we divided to change them, let's multiply to change them back. First, we multiply the denominator by the whole number. Once we find that product, we add it to the numerator of our mixed numbers fraction. Then we put that number all over the original denominator to get our improper fraction. So in the end, mixed numbers and improper fractions can express the same number in two different ways. It's up to you to decide which is better, improper or mixed.
Who am I? Well, I never.
Original denominator.
Okay, so you see the video there just reviewing mixed numbers and improper fractions. And so now we're going to look at the math message here. And it says fractions greater than 1 can be written in many ways. So you see example here, they use fraction circle. If one whole circle is worth 1, what is 3 whole circles? And then we see here we have 1, 2, 3, 4, 5. And there's one piece missing. So it would be 3 whole circles plus 5/6 of another. So another fraction name for that could be 23/6. So what I could do is convert my mixed number to an improper fraction by multiplying the denominator times the whole number plus the numerator. So when I do that, just like in the video, I get 18 plus 3, which ends up being 23/6. So I could say that inside of all these, there's 23 pieces, and each circle is worth 6/6. Okay, so we're going to look at a couple of these together, and then you're going to practice on your own. So this one here, you could use fraction circle pieces or fraction number line poster, but I just like to use the trick of multiplying and adding. So we're going to multiply, and we're going to add. So I know that 3 times 1 is 3, plus 2 is 5, so I get 5/3. I could also, if I wanted to, draw a picture with one whole box and draw a second and shade in 2/3 of the second one. I say I get 1, 2, 3, and then I could count. I have 1, 2, 3, 4, 5 thirds. Okay, so that's what you want to do on that. We'll do one more over here. We'll do 2 3/5, and we want to convert that to an improper fraction. So I multiply and then add, and I get 2 times 5 is 10, plus 3 is 13/5. And again, I could draw a picture for that if I needed to, or use fraction circle pieces, or if you have your fraction line poster to refer to. And then at the bottom, what you want to do is it says write the following fractions as whole numbers and mixed numbers with the greatest whole number possible. So you remember fractions can actually be read as division. So if we look at 7/3, really all I'm doing is saying 7 divided by 3 and writing my remainder as a fraction. So I know 2 times 3 is 6. When I subtract, I get 1. And so I have 2 1/3 left over. You should have the same denominator that you started with. And you write your remainder over that denominator. So let's look at 12 here. So we have 16/8, and we want to divide 16 by 8. Well, I know that 8 times 2 is 16. I do not have a remainder, which is fine. Because again, we're treating it like division. Sometimes you'll just have a whole number. So you're going to pause the video and work on the rest of those. So again, the mixed numbers there, you can draw a picture, or you can multiply your denominator times your whole number and add your numerator. Down here for the improper fractions, you want to simply read them as a division problem. Okay, so how would you solve this problem? 3/4 multiplied by 1/6. So let's see. We set it up. We know that when we multiply fractions, we just simply multiply straight across, right? So I would get 3/24 because 3 multiplied by 1 is 3, and 4 multiplied by 6 is 24. Now, how would solving 2 multiplied by 2 1/3 be different? So let's think about that a minute. Let's actually do that. So I'm going to do it over here. So 2, let's set up 2 multiplied by 1 2/3. Now, if we look at that, it looks a lot different than what we had over here. What I want to do is I want it to look like that over there. So what I'm going to do is put my whole number over 1 because I know 2 divided by 1 is 2. And I'm going to go ahead and make this an improper fraction. It makes it easier for me to multiply. So I know 3 times 1 is 3 plus 2 is 5. So I get 5/3. And now it looks just like the problem we had over there. I get 10/3. But I don't want to leave it like that because if I was to go to the deli and ask for 10/3 pounds of meat, they might get a little confused. So now I want to convert that, and I know that 3 is 10 is divided by 3. So I know 3 times 3 is 9, and I get 3 1/3. Now, if I went to the deli and said I need 3 1/3 pounds, that'd be much easier for them to figure out. So when you see that, when you multiply a whole number or a fraction against a mixed number, you want to convert the mixed number to an improper fraction and just do simple fraction multiplication. So we just worked this one out. So you can go ahead and try that again if you want on your own. Now let's try this one together here. They even tell you the algorithm for the other problem up there, but let's look at this one together. This one has 2 mixed numbers. So I have 6 2/3 multiplied by 2 1/4. A common mistake is people just want to say 6 times 2, 6 times 1/4 and be done with it. The easiest way, in my opinion, is to make them improper fractions and then use simple multiplication. So 3 times 6 is 18 plus 2 is 20/3 multiplied by 2 times 8 is, or 2 times 4, sorry, is 8 plus 1 is 9/4. So then I can simply multiply across. I know that 2 times 9 is 18. I have a 0, so 180. 3 times 4 is 12. Again, I don't want to leave it as an improper fraction. That's where I want to actually do some converting. Right? And so for that, we would do division. So I could do 180 divided by 12. And I know that 12 can go into 18 one time. So I do 12, and there's a 0, so I could do 10, and I end up with 60. And I just know in my head that 5 times 12 is 60, so I get 15. If you didn't know that, you could work it out until you get to 15. But this is equal to 15. And again, you could always check that by saying 12 times 15 to see if that's correct. So you want to convert your mixed numbers to improper fractions, multiply straight across. Then if you have an improper fraction as your product, you want to convert it back to a mixed number. Okay. And so here's some other problems for you to try. So go ahead and pause the video and try the next 2 problems. Okay, hopefully you had a chance to try the other 2 problems there. Let's look at those together. So let's look at this one. 7/8 multiplied by 5 1/2. So again, the second one's mixed number. I want to convert it. Do 11 over 2. And I get 77/16. Not going to work though. I need to convert it. So I'm going to do 77 divided by 16. And let's see here. I can't do 10. That'd be 160. I think I could do 5. Let's see. I'm just going to try it out here. 16 times 5. I get 30. That gets me to 80. Oop, too high, so it has to be 4, right? So I'm going to do 16 times 4. And that gets me, see, 40, 64. And I get 13 left over, and that's going to be our remainder. So I'm going to have a quotient of 4 and 13/16. So either answer is correct, 77/16. But we really want to convert it to a mixed number there. And we simply do that by dividing. Okay. Now, in your math journal, you're going to look at these problems here. So let's look at the first two. It says, rename any mixed numbers as fractions. Rewrite the problem using the fractions as factors, and use a fraction multiplication algorithm to solve. Okay, so this one here, I'm going to convert both of those to improper fractions. On this one, the first one needs converted. So you're going to go ahead and solve those. But let's look at problems 3 through 5 before you begin. Write a number model using a letter for the unknown, then solve using a fraction multiplication algorithm. Show your work. What is the area of the notebook paper? Well, I remember when I see area, it's length times width times height. Oh, that's actually volume. It's just simply length times width for area, right? And that's what I'm trying to find. Now, it does say to use a letter for the unknown. Unknown is our answer, so we don't know that yet. So we're going to say 10.5 multiplied by 8 equals, I'm going to say P for paper. You can put whatever letter you want there. And then you're actually going to go through and solve it. Same thing here. We know area, so it's length times width, and they give us both of those dimensions. So my number model would be 2 1/3 multiply 3 3/5. That equals, I'm going to just say F for flag. And then you would solve those. So again, if they're mixed numbers, you want to convert them to improper fractions and then multiply straight across. If you have a problem with a whole number factor, like here, you want to put the whole number over 1 and multiply across. Then if you look at 5, you have a couple more story problems there. Last week, Aaron earned $9 during chores. So if I use cubes there, I see earned $9 during chores. Dara earned 2 times as much. How much money did Dara earn? Well, I know that 2.5 times as much means I'm going to multiply, right? So you're going to do 2.5 multiplied by 9, and that will tell you how much Dara earned. And then number 6, you're going to write a number story that could be solved by multiplying 1.5 and 4.5. So for example, I might say something like, I earned $1.5 mowing my neighbor's yard, and my friend came and mowed the yard later and got paid 4 1/4 times more than I did. So obviously got the better deal. So think of something where you got something that was 1.5, but then someone got 4 1/4 greater than you. And you're going to write a story problem there. And you want to make sure that it comes out with multiplication. And that's it for today. So you can always practice on Excel if you're still struggling with that, or ask your teacher. Have a great day.